In this example, we have that a loaded barge is being towed by two tugboats, and the magnitude of the resultant is 5,800 pounds, directed along the axis of the barge. We will find the tension in the tow lines if they each make an angle of A equals 27 degrees with the axis of the barge. We will approximate the answer to one decimal place. A couple things I'm going to say about this up front. First, there are multiple methods to evaluate this problem. There's one that uses traditional vector techniques, which would involve writing both vectors for the tugboats in component form by using polar component form, since we can evaluate and write down the magnitudes and their direction angles. However, the method I'm going to demonstrate here will instead redraw the situation of vectors by considering how you can geometrically represent the addition of vectors. The second thing I will mention is, notice the problem says to approximate the answer, instead of finding multiple answers, since we have two tensions for two tugboats. However, the reason it says that there is one answer and approximate the answer is because both tugboats are making the same angle measure with the axis, meaning that one of them is not pulling any more than the other. So they should have the same amount of pounds of force. So keep that in mind. The way that I'm going to work with this, I'm going to consider this tugboat situation as an addition of vectors. We have our first vector here. I'll consider the vector for the top tugboat. So I'll draw that vector here. The vector for that first tugboat there. That is combining with the other tugboat to result in 5,800 pounds of force along the axis of the barge there. So that tension vector, and if I add that to the other tension vector, which if you notice is going down and to the right, I will start that from the terminal point of the first vector as going down and to the right. And the resultant, or from the first initial point to the last terminal point, that should correspond to the 5,800 pounds of force along that axis. So that's our 5,800 pounds of force. We are tasked to find how much each tension of the tow line is in pounds. So we're going to be finding these values here, the side lengths or the magnitudes of these two tension vectors, which, because they make the same angle measure with the axis, we have that with the horizontal axis and the diagonal line for the first vector, we are told that is 27 degrees, as well as the horizontal line with the other vector is also 27 degrees. This is essentially creating an isosceles triangle, meaning that both of these side lengths should be equal. We have at this point enough information to solve for the third remaining angle measure without too much work, because the third angle measure here should be the supplement of the other two. So 180 degrees minus 27 degrees minus another 27 degrees, or 54 total. That would be 126 degrees. With all this information in mind, if I want to redraw this, I essentially have an isosceles triangle where I know this side length is 5,800. The other side lengths are both x. I have an angle of 27 degrees here, an angle of 27 degrees here, and this angle of 126 degrees. That means I have enough information to evaluate and use the law of sines and cosines. In particular here, because we do know a side length and an angle measure across from that, we should be able to use law of sines. So I will do that here to solve for x. I will set x to be over sine of the angle measure across from x, which in both circumstances here is the same angle measure of 27 degrees. X is across from 27 degrees. And I will set that equal to the ratio of the magnitude we do know, or the side length we do know, of 5800 divided by sine of the angle measure across from that. 5800 is across from the angle measure of 126, so that'll be 58 divided by sine of 126 degrees. Solving for x there doesn't take too much. Just multiply sine of 27 over to the right side there to get 5800 sine of 27 degrees divided by sine of 126 degrees, which we should be able to approximate to 1 decimal place. Let's use a calculator for that purpose. So we have 5800 times sine of 27. We will divide that by sine of 126. Make sure you're in degree mode since we plugged in 27 degrees and 126 degrees. And you should get approximately 3,254.7 to 1 decimal place pounds. And that should be our solution here. Do note that our final answer there, 3254, would be the tension for each of these tugboats. And that means that together they are adding up to more than 5,800 pounds of force. We should expect that because when you are splitting the force in this way, you are dividing it up so that less force needs to be taken up by each entity. But because of the angle measure that you're introducing to this, that means the force is less efficient. So that means together, the two forces are going to add up to more than what they are overall resulting in. Hence why we get this triangle diagram.